Welcome back. Okay, in the last video I covered tiling, particularly the hexagons. And I had mentioned that lines are clipped so they don't pass beyond normalized space. Now if I hit the tile button, I change the radii and different clipping occurs. Also, since I'm not changing the number of rows and columns, you end up with quite a bit of hexagons that are actually outside of the normalized space. Now, obviously, when I refer to a line, I'm really talking about a line segment. We don't really have to say much about that. That's obvious. There's three conditions you can run into. A line can be completely within normalized space. A line can be completely outside of normalized space, or a line can be partially inside normalized space. Now, in the case of it being, you want to be efficient about lines that are inside. You want to throw away lines that are completely outside. And when you need to clip a line, when it's partially inside, then it becomes an issue of, well, which point, P1 or P2, and in what manner? What is it crossing? Let's go over to the code and look at the algorithm. Okay, to the line structure, I've added a function called clip_append. I'm going to start by assuming that all four variables, the two x's and the two y's, fall within normalized space. And then I'm going to test. I'm going to test the two x's and the two y's. If any of them fall outside, in other words, greater than 1 or less than 0, I indicate a false. So I have four Boolean values. Now, if I AND them all together, Boolean algebra, and they're all still true, in other words, the line is actually within normalized space, hopefully that's the most common condition, I want to append the line as it is to the lines array, and I want to return. So I want an early out. At that point, what I do is I determine whether the line is completely outside of normalized space. So if P1 is not within and P2 is not within, I want to return. I want to completely ignore the line. It's irrelevant. Now we're in a situation where one of the 2 points is within and the other point is without. So I want to test P1 first. If P1 is, then P2 is out of bounds. So I have a new function on the PT2D structure, which is called clip. And what that does is it pulls the point back to where it crosses the boundary of normalized space. Once I've done that, I need to create a new line segment. And I want to append that one. Then I want to return. If we got below that, then it's P1 that's the problem. So P1 is operated on, and that is returned. Now going up to the case where it's with inside, it returns self, and that just simply means return the line that I'm currently operating on. The line has not been modified. You have not seen this function invoked yet. It'll show up when we start talking about simple polygons, which is what the hexagon is. If I go up to the PT2D structure, let's take a look at clip. I want to do 4 things. I want to see whether x is greater than 1. If it is, I want to set it equal to 1. So in other words, I'm pulling it back. If x is less than 0, I want to set it to 0. The same situations for the y. Greater than 1, less than 0, and less than 0, set it equal to 0. Now you'll note that if the first condition, the first if, is fired, the second one is irrelevant. And the same for the third. If it fires, it makes the fourth irrelevant. I did not put the else's in. I think part of that's laziness. The other is that which is more efficient depends on what the optimizer actually does. Is the second test actually take less real time than the actual jump that could be caused by the else statement? That's it. Have a great day.